Good morning, Year 9. This is Miss Teresa. Today we are going to discuss work. Our lesson objective to discuss the conditions that define work and success criteria. I can define work and explain that work done is equal to force times displacement. Look at this man doing some exercise. You might think that he is doing work. In the conventional meaning of work, yes, he is doing exercise, hence doing some work. But according to physics, he's not doing work. So, what is work according to physics? Work in physics is the measure of energy transfer that occurs when an object is moved over a distance by an external force which is applied in the direction of the displacement. The three key ingredients to work are force, displacement, and of course the cause. In order for a force to qualify as having work done on an object, there must be a displacement, and the force must cause the displacement. The displacement should be in the direction of the force. Work is done whenever a force makes something move. The greater the force and the greater the displacement moved, the more work is done. When work is done, energy is transferred from one form to another. Now, let's analyze whether work is done in these situations or not. A child applies a force to a wall and becomes exhausted. Although he got exhausted, there is no work done because there is no displacement. A book falls off a table and free falls to the ground. There is work done because the book fell through a distance. A rocket accelerates through space. Yes, there's work done. A horse pulling a carriage. Yes, there's work done. A student lifting a backpack full of books upon his shoulder. Of course, yes, there's work done. A teacher teaching online for 7 hours a day. There's no work done for that. Although we do a lot of work sitting all day, but we didn't go through any distance. Therefore, no work done according to physics. A waiter carries a tray full of meals above his head by one arm straight across the room at a constant speed. What do you think is the answer to this? Is there work done? Is there no work done? In this case, there's no work done. You might be asking why the waiter did not do work, yet he moved from one point to another. The waiter does not do work upon the tray as he carries it across the room. The force supplied by the waiter on the tray is upward force, and the displacement of the tray is a horizontal displacement. In this case, the direction of force is not according to the direction of the displacement, so there's no work done. The equations related to work are the following. Work done by applying force on an object which travels horizontally in the direction of applied force. Work done is equal to force times displacement. In symbols, work done is equal to F times D. Work done against gravity. Work done is equal to force times height in symbol, F times H. And since force is equal to m times g, g is the gravitational field strength, which is always 10 Newton per kilogram, then work done is also m into g into h. The following are the SI units related to work. Force is measured in Newton, distance is measured in meter, and work done is measured in Newton meter or joules. 1 Newton meter is equal to 1 joule. Now, let's go and solve some IGCSE type questions. First question. In the following list, take the two boxes next to the two quantities needed to calculate the work done on an object. So here are the lists: mass of the object, force acting on the object, speed of the object, acceleration of the object, and distance moved by the object. This is easy. How do you know it's easy? Because we already know that for work done is equal to force times distance, right? Displacement. Therefore, distance, displacement, and then force acting on the object should be the answer. So that's quite easy to understand and easy to answer. Next question. It's a little bit more difficult because this is a problem solving question. Okay, let's read. On a day with no wind, a fountain in Switzerland propels 30,000 kilograms of water per minute to a height of 140 meters. Calculate the work done against gravity through this height. So work done due to gravity, earlier we said it's work done is equal to force times height. Okay, the force here is not given, but we can solve for it. It's mass, which is given. But we know that F into H is also equal to mgh because F is equal to m into g. Why? Because that's also the weight. Weight is a type of force. Therefore, F is equal to m into g. Okay, we're going to calculate this now. So m into g into h. Okay, h. M is the mass here given is 30,000 times 10, which is the gravitational field strength, times the height, which is 140 meters. We don't need to convert one to another because it's already all in SI units, proper SI units. Now 30,000 times 10 times 140 is equal to 4.2 times 10 raised to 7. Okay, let's clear this up. It's work done now is equal to 30,000, let me write it again, times 10 times 140. No conversions needed, therefore the final answer will be 4.2 times 10 raised to the power of 7. And the SI unit is Newton meter or joule. Joule is fine. Okay, so that's the answer for this problem. So it's easy. Okay, let's go to the next one. You already know that the last problem will be for you to solve. So I want you to solve this question in your notebooks, take a photo and upload it in assignments part of Teams, not in the private chat anymore. You have to put it in assignments so that I can put some mark and some grade. I can grade it. Okay, so what have we learned today? Our lesson objective was to discuss the conditions that define work, and we really did that. And I can define work and explain that work done is equal to force times displacement. We also did that. Okay, so I hope you enjoyed our lesson for today and have a nice day. This is Mr. Essa. Bye.